Yeah.
Okay, so then log base 2 of b is going to be log base 2 of the quadratic, x squared plus 6x plus 9. Okay? And then log base 2 of a is going to be log base 2 of 4. Do we see that?
Uh-huh. Where
Uh-huh.
did the other quadratic go?
What other quadratic? Are we talking about like all?
Beside log 2.
Oh, this one. Oh, yeah, this
Yeah.
this one's this one's still chilling. It's still out here.
Oh.
Yeah, this one came down here. This one came over here, and then this one came over here.
Oh,
I see.
I
Maybe you
thought it
thought
just
maybe you thought we
disappeared.
were doing.
Okay.
Yeah, yeah. You're good. All good.
Yeah.
All good. All good. Okay. Nice. Okay. So the next thing I want to do here is I would like to combine all these quadratics. It would be kind of nice. Is I'm going to multiply everything by the least common multiple, which in this case is 6, right? Um, so I can say, okay, cool. I'm gonna multiply this by 6 over 6. I'm gonna multiply this by 3 over 3. I'm gonna multiply this by 2 over 2. Do you see how every time we're still multiplying by 1?
Mm.
Okay. You're always allowed to multiply things by 1. That doesn't change anything, so that's good. Okay. So then doing so, we'll then get that everything here is over 6. Okay. So I'll get, okay, 6 log base 2 of x squared minus 3x plus 2, right? Minus 3 log base 2 of x squared plus 6x plus 9 plus 2 log base 2, and then that's going to be x plus 3 to the 6. And then all of this is over the common denominator of 6. Okay, and then this is all equal to log base 2 of 6. Does that make sense so far? Going that direction?
Yeah.
Okay, cool. All right. So, I'm gonna move this 6 over. Okay, so then I have 6 log base 2 of 6, which is the same thing as log base 2 of 6 to the 6.
Mm-hmm.
Yeah, yeah. Uh, can't you bring the exponent of 6 down to the front for the third term? Oh, you're actually quite right. Yeah, I could have done that. Yeah, that would have been a simplification. You're right, Yashua. Yeah, I could have done that. Yashua brought up a good point of like, I could have dropped this 6 already. Which will end up canceling something, but I wanted to keep everything as the same denominator. We'll worry about the exponents in a bit. Okay, cool. Okay, and then that's equal to, right, this goes away, so you have all of this. And now I'm going to start putting everything up into the exponents, okay? So I'm going to put this on the top, I'm going to put this on the top, and I'm going to put this on the top. So this is going to be log base 2 of x squared minus 3x plus 2, all to the 6th, minus log base 2 x squared plus 6x plus 9, all to the 3rd, plus log base 2 of x plus 3 to the 12th. So I'm like running out of room here. And yeah. What's up, 1K? Good to see you, dude. And the reason for that, right, is if I bring this up, it's like to the 6th to the 2nd, but exponent to an exponent means you multiply the exponents. Right?
Yeah.
Cool? All right, awesome. Now, the reason I did this, Mika, is that now I can use logarithm rules to combine these all together. As long as these are like what I call like naked, like there's nothing out front, there's nothing weird happening, you can then say, oh, I know the log of something minus the log of something else, right? Is the log of those two things divided by each other?
Mm-hmm.
Right? So I'm going to say, okay, cool. So this is the same thing as the log base 2 of, and then this is going to be x squared minus 3x plus 2, all to the 6th. And then we're going to say divided by this one, x squared plus 6x plus 9, all to the 3rd. Okay, so that would combine these two into a single log. And then we're adding another log. So what does that do if I want to bring that inside?
Multiply.
Multiply. Good. So then, and then this is also going to be multiplied by x plus 3 to the 12th. Okay. Okay. I know this is a doozy, but this is fun. I think this is fun because I know these are pretty simple things to factor,
Yeah.
and we're probably going to get a bunch of shit just canceling each other. Okay. So this is going to be log base 2, and then so x squared minus 3x plus 2 can be broken up into what? So it has to
Minus 2 minus 1.
Good. All good. Yeah. And again, for those that are watching, like, this is why you learn all this stuff in like algebra and whatnot. You're like, probably like, bro, why do I need to know how to factor and stuff? It's because it comes up in the harder questions later. Like, you want to be able to know pretty quickly that this is cool. This is x minus 1, x minus 2. Yeah, Mika got it. Good. Okay. But then that's all to the 6th. Okay. So I have x minus 1 to the 6th, x minus 2 to the 6th, right? Over. And then what's this one? Yeah, quadratic functions. Yeah, these are quadratic functions. Well, actually, technically, they're like pentic or like, I don't know, they're really high because like it's a quadratic function to the 6th, which is super annoying. Good to see you, Mulberry. Okay. So then this is just x plus 3 squared, right? So this becomes x plus 3 to the 6th. Do we see that so far?
Mm-hmm.
Okay. And then this is times x plus 3 to the 12th. Okay? Some cool stuff that's going to happen here, right? Notice how I have an x plus 3 to the 6th and I have an x plus 3 to the 12th. So this can go away. And then we're just going to write this as a to the 6th. Ooh. Yeah, kind of cool, yeah. Okay. Okay, so keep going. So again, log base 2 of 6 to the 6th is equal to the log base 2. And notice how all of these things are now to the 6th, okay? So I can say that's x minus 1, x minus 2, x plus 3, all to the 6th, right? Because it hits every single thing, which is nice because now if I bring this out front and I bring this out front, right, those are going to go away. So I don't even need to worry about these. So these go away as well. Okay? So now I have log base 2 of 6 is equal to the log base 2 of x minus 1, x minus 2, x plus 3. So that just means this thing equals this thing. Okay? So now I have 6 is equal to x minus 1, x plus x minus 2, x plus 3. It'd be so nice if this was 0. Because then we could just be like, oh, it's all the factors, like whatever. But they made it equal to 6. Okay.
Yeah.
So I gotta like foil this, right?
How you feeling?
It's annoying. Oh, x equals 0 works. Oh, it does. Oh. Jeff is hilarious, dude. Okay. Yeah. But here's the question. Here's the problem, Jeff. Is that it's the length of the park's layout. So the length is not allowed to equal 0.
No.
Right? Just so Jeff is correct here, right? That if I just plugged in 0, I would get 6 because you'd get -1 times -2, which is 2, times 3, which is 6. So it does work. The issue is that, again, yeah, this is a trivial solution because you can't have the park with a length of 0. That'd be like an infinitely thin park. Okay. I guess I just gotta foil it. It's annoying. Okay. X squared. Someone keep me honest if I'm wrong here. 6 to the 0 is equal to 1. Oh, okay. So that's also the point here. Do you see how here they say specify any necessary restrictions? I guess, yeah, because what we're going to have to do eventually is plug back in values for x and make sure that we're not taking the logarithm of negative numbers. Which we're not with 0. That's okay. But I guess that would work. Anyways, all right, let's just keep going. Okay. X squared minus 3x plus 2 times x plus 3. Oh, which was... Oh, okay. I see. We could have just taken this and then just factored it because this is all the same stuff. Okay. I see. I ended up factoring everything completely because I just wanted to see if other things canceled, but they didn't. Okay, and then this is where some people get so mad at me for doing this, the Punnett square method, but to me, I don't know. This like keeps me honest so much easier than doing FOIL because like I forget like which one I did. I don't remember. Especially now with COVID brain. Okay, so this is x cubed. This is 3x squared. And you can ask me, Mika, if you don't follow like what I'm doing here. But it's basically just FOIL. What I do is I like multiply this by this, and then I get like an answer. And then I just do it sequentially across everything. Okay. So that gets me 6 is equal to x cubed. Oh, this goes away. Is that real? Is this real life? Oh, nice. Okay, cool. Yeah, goodbye. X cubed. And then what's that? Minus 7x plus 6. Oh, equal to 6. Oh, here's where our 0 comes from. This is actually really cool, Mika. Do you see this? So if I subtract 6 on both sides, right? I get 0 is equal to x cubed minus 7x. Okay. So then if I move that over, right, I get 7x is equal to x cubed. And this is where the 0 solution comes from, because if I divide both sides by x, I get that x squared is equal to 7. Okay. Which means, and this is another thing, just in algebra in general, you have to be careful. Be careful here. That you don't forget that x is equal to 0 is a solution. You're just like tucking it under the rug, like you're getting rid of it when you divide by x on both sides. Okay, so x is equal to plus or minus the square root of 7. And again, it doesn't make sense for the length to be negative, so x is just equal to positive 7. The square root of 7, sorry. Yeah. That's the answer.
Oh, okay.
I think.
Wow.
Technically, I think you should also plug it back in and just make sure that none of these things end up being negative. But given that, like, one of my answers was 0, the other answer was, like, was a negative number, which length can't be negative, and I assume this question has to have a correct answer, I'm going to assume it's just this one. If there were more answers, if I had, like, this, like, 3 and then 5, I would check these other ones to make sure that we're not taking the log of a negative number. But seeing as this is the only positive one that makes sense, it has to be the answer. So, yeah. Cool. Does that make a little bit more sense to you, Mika?
Yeah.
Yeah.
Thank you so much.
You're very welcome.
Screenshot it?
Pardon? Yeah, I will screenshot this. Yeah, this is a fucking mess.
Thank you.
What does length, the part of the park, mean? I don't know. We'll go see it. One sec. Okay. Yeah. Mika, and this was part B. Or whatever. I don't know. I don't think I've ever used as many logs in my entire life. I don't think I have either, honestly. It was quite... Again, I think it's fun. It's cruel, but it was fun. Because I thought it was cool to like go through, to remember all the logarithm rules and then factoring and stuff. Yeah, it's cool. All right, awesome. Let me help out some other students, Mika, and then if I have time, I can run back on your other question you got. It looks like you have something with like tangent and
Oh yeah,
secant in
I
there.
think I'll take a break right now.
All right, yeah, go take a break, enjoy some stuff. Yeah, let the brain decompress, and yeah, we'll come back to it.
Thank you.
You're very welcome. Nice. Okay, that was a fun one. Okay. Cool. Let's see. Christian, Ronaldo. Oh, we got Ace first. Ace is first, and then Christian. Hey, Christian, I'm gonna teach you something new because just asking what the square root of 144 is not really a question.
I have returned.
Yes.
Fear me.
Oh no.
What's up, sensation? Did you see that thing I posted about the Scouse guy?
What?
Patty, what's his face? One sec. I sent it in. Where did I put it in the comment area? This guy right here.
What did I tell you, Mike? Me and you will be having this conversation after
you know
the
this
first
guy?
round finish. And what happened?
Well, I'll tell you what happened. You almost got knocked out. You got caught with a beautiful left hook. But come on, hey, listen, it's not how you start, it's how you finish, and you finished in style.
You know me saying, lad, I'm a scouser. We don't get knocked out. Hey, I take that all day. What
It's like I'm a scouser. We don't get knocked out.
It's true. Scousers don't get knocked out.
Scousers don't get knocked out. Yeah. Scousers don't get knocked out. Except maybe when they have too many pints. I would say then they maybe do get knocked out. They don't get knocked out by somebody else. They may knock themselves out. Oh man. Your voice sounds a little different, Sensation. Did you get a new mic, or are you also like me, like fighting like an illness?
I've just woken up.
Oh, this is his I just woke up voice. Cool. Yeah. I know that. Wait, what?
Hence,
What time?
hence,
What time?
hence the lack of luck because I'm still in my gym jams.
Oh, there you go. He's like, I still got to look proper. Yeah, Asner, you are correct. Yes, Asner solved that one pretty quickly. Time UK. It is currently 11:50 p.m. for our others. Yeah, side of the pond. Nice. Yeah. Well, make your cup of Joe. That's get out of
Indeed.
the. I call them my give up on life clothes, like my sweatpants. I'm just like I just gave up on life. I'm wearing sweatpants today, because I slept for 14 hours last night and then just woke up this morning like feeling rotten, and I'm just like, okay, I'm not putting on like actual clothes. Thankfully, all the students I have to teach today is all online, so I don't have to go in person to see anybody.
See, I don't own anything other than camouflage trousers.
There you go. Camera's nice. Yeah.
I've got dark camouflage trousers and I've got jungle camouflage trousers.
Do you have the desert ones? You need some desert camo.
No, because obviously that's like our real colors, so can't do it.
Oh, okay, I see. Can't have the real stuff.
I can wear your colours all day long in the UK, but I can't wear our colours all day long in the UK because
Then people think you're actually part of the military or something.
Yeah.
You start getting saluted in fucking Tesco.
Oh, don't. Some of the cadets I do actually know who I am.
Oh wow. Okay, there you go.
And have started doing that, and it's just like, don't. It was
Don't.
20 years ago.
Don't.
Fucking
Don't.
back it in.
Don't blow my cover. Oh man. All right, where are we going? Oh, what's up, Ace? Okay, Ace, here, listen to your question. A child swings on a swing with 1.2 meters of amplitude. Find the total horizontal distance traveled by the child in 3 full cycles or oscillations. Interesting.
So the child's going over the bars and then back around again.
Yeah, I'm confused. Sorry, what? Yeah. Is he going like? Is he spinning around like a fucking like yo-yo? Like, what's going on here, dude? This is a funny question. Did your teacher seriously give this to you, Ace? Because yeah, Sensation's right. Like, if this was the yes, indeed. Okay, man, Jesus. Yeah, because if we're talking about like full oscillations, that means that they're doing this. Which I don't know. That's not healthy for the child. Okay. I assume they're talking about that this to this is 1.2 meters in amplitude, okay? I assume they're talking about this. Yeah, I assume they're talking about this. Interesting they say total horizontal distance, right? Because I don't know, because this is like a, curvilinear. It's a curve, right? So it's like that. And then yeah, bro beat gravity. He's like, he beat the fuck out of gravity. It's like, can't touch me, dog. Okay. I assume like from here to here is this is such a weird question because I think I need to know the length of the swing, right? I assume we're talking about this. This is 1.2 meters. This is such a weird question. Yeah, total distance is just yeah, but don't I need to know how long the swing is? Because 1.2 meters of vertical displacement depends on how long this is. right? Am I crazy?
Well, it sounds about right.
Yeah.
Can you not derive the length of the chain from the amplitude?
Correct.
Don't you usually need 2 pieces of data to do that?
Yeah. I don't need like the child's. It is a pendulum problem, Yashua. You're correct. But I don't think there's an equation for horizontal, whatever, like displacement with isosceles triangle. Okay, maybe. But then I need to know what this angle is. I don't. Okay, whatever. Let's try to do this. I think. Yeah, I think Jeff might be onto something. So okay.
Wait,
So
what if it's an equilateral triangle?
Well, we don't know that it's equilateral. It doesn't say that. Okay, we know it's isosceles, right? Because the length of the chain is always constant. So this is always equal to this. And then we know that this distance right here is 1.2. Right? This is 1.2. So I don't know this, and I don't know this. I am trying to figure this out. I do want to know this.
Feels like information's missing, to be honest with you.
I feel like something is missing. Ace, is there more to this question, dog? Gotta be more to this.
Show us the whole page, please.
Yeah, it shows here. What's going on here? I don't think
More.
more. M-O-A-R, dog. I need more.
More.
More. More mudkips, please. I heard you like mudkips. Yeah, who's old enough to know the mudkips meme?
I'm old enough to remember mudkips.
Yeah, mudkips. Oh yeah, there you go. Oh, you could call the chain length as X and see if it drops out. Yeah, I could, I guess. I just see like a triangle that I can't fucking solve for. It would be 1 point. Yeah, but that would be the vertical distance. We want the horizontal distance. Horizontal distance, I believe, is this way. You're correct that it would just be 4. It would just be 4 times 1.2. If we so maybe there's a typo here. Maybe your teacher fucked up horizontal with vertical. Do you know what the answer is, Ace? Do you have the answer? Yes. What's the answer?
I mean, you could always just slam it into ChatGPT and say, "What's the source of this?"
There we go. Yeah. Or I could just like throw it into what is it? Let's go to ChatGPT. The answer is 14.4? Dude, what? How? I want to see this.
Somebody's fucking with somebody there.
Four times 1.2 times 3. Interesting. Okay, let's see why that is.
The answer that ChatGPT spat out was half of what Ace
Yeah,
just gave you.
ChatGPT said it was 7.2. I'd say like apparently the correct answer is 14.4. Let's just even come up with an explanation. Yeah, bro. Yeah. Wait. So when I asked, do you have the answer? I mean, do you have the teacher's answer, not ChatGPT's answer? Because ChatGPT can be wrong.
ChatGPT usually is wrong.
Okay. I get it. Okay. So this question is shittily written. Because what they should have said is that the 1.2 meters in amplitude is the horizontal amplitude displacement. Okay? Usually when we talk about a pendulum and like amplitude, we're measuring what the height of something is. Okay? Okay. Misunderstanding on my part. Well, not misunderstanding, just like shitty writing on his part. Okay, cool. This is 1.2. Then yes, in one complete oscillation, right? So one oscillation is always going from the starting point to the end point in like the same pattern, right? So we would go 2.4 this way and then 2.4 back, right? So that's 4.8 in a single oscillation, which, yes, times 3 then gets you 14.4. Okay, thank you. Yeah, I see it. Weird, man. Dude, what? Yeah, so your teacher is calling the amplitude. He should have said it's one. He should have said the 1.2 is the horizontal amplitude. Okay. Yeah, and I guess that's a cute little diagram of it. Yeah. You know, he does bring up a good point, which this is what sometimes people will get wrong. They will think that a cycle is when something returns to its original position, which is not exactly correct. It has to return to its original position and be going in the same direction, like have the same velocity. So, for instance, some people will be like, oh, you know, here and here, it's at the same position, so that must be one complete cycle. But this is not correct.
No.
You gotta be careful here. It's because here it's moving from positive to negative, right? And then here it's moving from negative to positive. So that is not one complete cycle. If you continued this graph out, let's say we continued it out this way, okay? Then one complete amplitude would be from here to here. That would be correct. Because in both positions, you're at amplitude is equal to 0, and you're both going down. Okay, just like a thing to look out for, Ace. Okay? Yeah. So, yeah, one complete cycle is the same starting and ending position, but it also needs to be going in the same direction. So it's not this one.
No.
Cool? All right, that's a cool question. It's pretty badly written, but whatever.
Nice.
No, that's not your fault.
Well done.
Never apologize for your teacher's, like, shitty teaching. It's never your fault, guys. I had
Which
one...
brings me to-
What's up? What's that sensation? Brings you to what?
Which brings me to another good point. Always gather your own info.
Yeah. Yeah.
Never leave it to somebody else because they can fuck it up.
They can definitely mess it up, dude. It happens. You know, it's interesting. I actually had a student I was working with, kind of like virtually online. Well, the mom is like really trying to like help them out by like teaching, and she's getting super confused. And here, let me find it. Yeah. Yeah, this is a good one. Yeah. So just a little example of like what can go wrong. This was this teacher is like trying to teach physics, and so they're writing their own physics questions, but in this case they end up giving too much information, and the information is conflicting. So the example I want to use is right here. I'll show you how that happens. So here they say a boy kicks a football with an initial velocity of this. At I think there was like some angle or something that has 8 seconds of airtime, right? 1 second. Let me there's more to this question. I remember.
Why do I immediately think it's like Suvac conflicting with KE or something?
Yeah. Okay, yeah. Here it was. This is the question. Yeah, here we go. This is what I want. Sorry, this is it.
Oh, Ardash is in the hizzy.
What's up, Ash? Ash is here? Where's Ash?
Ardash 2009.
Oh, Adarsh.
Adarsh.
You gotta pronounce those names correct, too. What? Come on, Sensation, dude. Ardash?
I can't see.
I can't see. You need to put your glasses on. Okay. Here it says, a boy kicks a football with an initial velocity of 28 meters per second at an angle of 30 degrees before the horizontal. And then they say it travels 2.5 meters in the x direction before reaching its highest point. Okay. So, and they say, how long does it take from kickoff to touchdown? Okay. So, if something travels 2.5 meters to go from the lowest point to the highest point, then it should take another 2.5 meters to get exactly. Thanks, Jeff. Yeah, that's exactly what I'm going to get at. For it to get to this point, right? Yeah, okay. So you could be like, okay, cool. So it needs to go 5 meters, right? And that's what they figured out. Oh, total is 5 meters. And then so to figure that out, right, I say that like Vx times t has to be equal to 5. And if it's 28 at 30 degrees, right, that means that Vx is equal to 28 cosine of 30. So let me get that real quick. So 28 cosine of 30, which is equal to 24 meters per second. Let's say like 24.25 meters per second, which you can plug in. And then you divide it out, and you get 5 divided by that for the time. And that gets you 0.21 seconds. So you get that like t is equal to 0.21 seconds. So if you did it that way, that's the answer. And I think that's the answer the teacher wanted you to get. However, if you were to actually do this problem on regular Earth and something, right? If this is traveling at 30 degrees and 28 meters per second, it does not travel 2.5 meters in the horizontal direction before it hits the top. The way to figure that out is to say that, okay, I know that the velocity in the y direction has to be 0 at the top. So I say 0 is equal to 28 sine of 30 degrees times t. Or sorry, 28 sine of 30 minus 9.8 t. So this ends up getting that 0 is equal to 14 minus 9.8 t. Let's just call this 10, just to be nice. And so that you get that t is equal to 1.4 seconds. Okay? So it does not hang in the air for 0.21 seconds. It hangs in the air for at least 2.8 seconds. And so these answers conflict with each other. Yeah. So it's a classic of example of like the teacher didn't need to give this information. They could have literally just stopped here, and then you can use other knowledge of how like physics and kinematics works to figure out how long it takes to go from kickoff to touchdown. That would just be this. It's 2.8 seconds. But by introducing that they told you what the horizontal displacement was, it's now not consistent. And the beautiful thing about physics is that you can always attack things from different equations and different like methods, and you'll still get the same answer. It's really cool. But this teacher is making that coolness go away. It's very I think the teacher's formulation was fine there. Yeah, you're right. Yeah. It's just weird, Poetica, because it's usually when we talk about pendulums and amplitudes, we talk about height. Horizontal, we don't usually care about horizontal as an amplitude. It's just not conventional, is what it is. This is blatantly wrong. And I thought it was really unfortunate because the student that I was trying to help with this, at some point I'm like, you're doing the right stuff, man, but your teacher is like setting you up to fail. And to be fair, it's the teacher's first time teaching physics, or AP physics, I think. So she's trying to help them as much as she can, but in doing so, like, making it more confusing. Anyways, okay.
Well, you've lost me now. How is a horizontal distance an amplitude? It should be a vertical distance.
No, because amplitude can be horizontal or vertical. Yeah, amplitude just refers to like peak to peak, and it can be measured in any direction. So, for instance, it's okay. Amplitude is usually, I know what you're saying, Sensation, because amplitude is usually a height, at least on a graph, right?
The height from normal.
Height from normal, right? Yeah. In this case, they're measuring the x position as the y-axis, and so like this is what's being measured, going back and forth, back and forth. And so, yes, even though, like, yes, amplitude usually means a height, and that's where my first thought came from, is that amplitude with pendulums is almost always measuring the height of something. But Jeff's right. If you're measuring a spring, yeah, but that's different, because the spring is not going up and down. The spring is going left to right, you know? I default to, if we're talking about pendulums, it's up down. If we're talking about springs and they're horizontal springs, then it's left right. Again, it's not the worst. It's not the worst question asked, but it's certainly better than this. This is just so hard.
No.
But
I'm
yeah,
half asleep, so I don't remember. So forgive me, but they're different types of wave at that point. Then a spring, the wave that goes through a spring is compression wave. I forgot.
Yeah, it's a compression wave. Yeah.
And then the other one's a standing wave, and
the other one is a. I think it's called
I know what it looks like. I can't. Yeah.
It's transverse. I think it's a transverse wave.
So yeah. One's transverse, one's longitudinal. There we go.
Yeah, there you go. Yeah, it's transverse. Transverse means that the amplitude is orthonormal to the propagation. So in the case of like if you have like a stick here and like your Puidica says they're used to horizontal amplitude for pendulums. Wow, I didn't know that. Never seen it. But maybe. But yeah, usually, so in this case, the amplitude, the up-down, is 90 degrees to the direction that the wave is going, okay? Whereas, yes, with a spring, right, we measure the compression as, like, the amplitude, and that's the same direction that the amplitude is, that the spring is moving. Pendulum's kind of interesting, I guess, because, because like I don't really know which way they're really like propagating, because they're kind of moving in this direction and in this direction. So, but if you're measuring the displacement this way and the movements that's this way, I guess technically it's a transverse wave, or technically, sorry, it's a parallel wave actually. That's actually let's ask ChatGPT. I'm just curious. What type of what's up, Equity? What type of wave is measuring the amplitude of a pendulum? Just see. Okay, so they just say mechanical wave. Okay, I've never heard that before.
So I've just remembered an old memory now.
No, you're right. Because I mean, in general, screwdriver. Look, there's usually it's like parallel, transverse. Is there another one? Oh no, it's called longitudinal. Longitudinal and transverse. Sorry, that's the word I was looking for. Yeah. This is it. Yeah, that's cool.
Just the word pendulum. I remember sitting in the back of a year 10 class shouting pendulous testicles.
Are pendulums longitudinal or transverse? I'm just curious.
I forgot about that.
Wait, what is pendulum? Because they look like testicles. Is that what you call it? Pendulum testicles?
Pendulous testicles. It was a thing that we must have heard at some point. But
oh, I've never heard of that before.
We got fully chewed out and got sent to the principal for that one.
Oh, man. Pendulums do not directly classify as longitudinal or transverse because they represent physical oscillatory motion, not a traveling wave. Oh, interesting. Yeah, right. Wasn't I saying, like, it's kind of hard to, like, determine where the wave is traveling? Because that's usually, in transverse, the motion of the particles is perpendicular to the direction of the wave. Great. Yeah, I agree with that. And then longitudinal is in the same direction. 25 stream streak. Okay, anyways. Cool pendulums and stuff. Let's see. Let's help out Cristiano Ronaldo, because Cristiano's got to ask a question. Although Cristiano, this isn't really a question. Asner was asking, like, why is he asking this question? It's because in our server, in order to get V-Bucks, you have to ask me a math question on the stream. So kids will sometimes just come up with absolute, like, nonsense for questions, and it's okay, because I'm going to ask them a real question.
What happened to his old account, anyway?
Whose old account? Cristiano Ronaldo. There was another Cristiano Ronaldo, but that's a different guy. I know, because CR7 is another. I know who you're talking about. CR7 is a different person.
Is it?
I'm pretty sure. Yeah.
Well, it's not what I'm seeing.
Oh, really? Well, you can do your research. I think they're all friends with Deba, is the original one. Unless Deba is creating multiple alts, but I don't think so. But yeah, they're all from, where are they from? Is it Romania? Or, what country are you from, Cristiano, dude? Somewhere in Europe. I remember that. Yes, Deba. Oh, Osner, yeah, you're all friends of Deba. Yeah, okay, yeah. I remember that. Yeah. And again, I'm glad Deba invited all you guys in. That's super cool. You guys are good. He's in 6th grade. Okay, cool. Well, thank you, Cristiano, for at least asking a question. Let me teach you something about it first, okay? If you're here, type in the chat. What's up, Moses? Good to see you, dude. To be fair, I finished all the questions except this one because this shit was confusing when I saw the answers, so I copied it down. Yeah, it's okay. Bosnia, yes, y'all are from Bosnia. That's super cool. Dude, I haven't even been to Bosnia. Wait, does Bosnia still exist, or is that like Yugoslavia that doesn't exist?
I can't remember.
Yes,
I remember loads of Bosnians came over here.
Yeah. Yes, he has 8 accounts of Discord for this. Oh, okay. Wait, is Deba the same person as Cristiano Ajner? Is it the same person or is it a new person? Oh, it's the same person. Okay. All right. Well, good to know. So yeah, Cristiano. Yeah. So you can't create alts. You can't. Yeah. You can't create alt accounts. Kids do this because they don't want to go through the progression of like tier 1, then tier 2, tier 3. Because tier 1's always the easiest one to get. Oh, he's not an alt? Okay, what? All right, I don't know, Asner. Oh, Doncic is from Bosnia. Yeah, isn't he? No, he's Croatian. Or he's Serbian? I think he's Serbian. But I know that like Serbians and Bosnians have like a little bit of history or something. Slovenian. Oh, very cool. Okay. All right, whatever. Here. All right, let's see here. Ajner, let me help you with yours because I think this is a cool one. Why is the density of ice less than the density of liquid water? How does this anomaly affect life in aquatic ecosystems? Okay, this is a pretty cool one. The answer for this, I believe, is hydrogen bonds. Someone correct me if I'm wrong. I think it's hydrogen bonds. So you'll learn this in chemistry, Ajner, and it has to do with atoms and elements can have different type of bonding between them. So you can have ionic bonds, you can have covalent bonds, and then there's a special type called hydrogen bonds, which is when hydrogen bonds with either nitrogen, oxygen, or I want to say fluorine. I think it's like HNOF. I think that's what it is. Hydrogen. ChatGPT is actually very good with chemistry. It's the one thing. I think there's a lot of information on the internet so that it gets a lot of it right. Let me see. What elements experience hydrogen bonding? Yeah, so it's fluorine, oxygen, nitrogen, and yeah, I was right. Yeah, HNOF. Okay, cool. Yeah. All right. And so because of this, these bonds are exceptionally strong and whatnot. So a lot of like weird things happen with water, for instance. So yeah, water gets less dense as it becomes a solid, which is weird. Because usually you have these states of matter, right? You have things that are, or here, let me get an image. I can find an image of this. We got like states of matter diagram. Yeah, something like, yeah, this is great, but I don't know why there's Shutterstock. I don't want Shutterstock. Can I have like something that's just like, yeah, here we go. Oh, and it has plasma in it. Cool. That's what I did. Okay, cool. All right. So we have solids, liquids, and gases. All right, and they can kind of be classified by how closely packed together the atoms are. So solids should be the most closely packed to each other. So this is what we would expect to have something with a high density. Okay, this would be like high density. Okay. Liquids, the atoms get to move around a little bit more, but they generally stay kind of close together. All right. And the important thing is like these will always fill whatever container that they're being held in. Whereas a gas, this is low density, and then these things go wherever they want to, okay? And then plasma, which is the fourth state of matter, it was what I did my PhD on. This is like an ionized gas, which means this is a gas where within the elements, the electrons have been stripped off, and now the electrons are free to go and do whatever they want. So yeah, these are the 3 different types. So usually as things become more like solid, like they should have a higher density. However, water does not. Water, if you've ever noticed, right? Like ice floats. If you put ice, which is solid water, in a drink, it usually floats to the top, right? And I believe the reason for this is hydrogen bonding. I think the bonding is so strong that it creates like some sort of lattice thing. Let's see. Why is ice less dense than liquid water? You'll probably tell me. They say hydrogen bonding as well. Cool. That's what I thought. Okay, in liquid water, the hydrogen bonds are closely breaking and forming, allowing them to pack closely together. Okay, very cool. So yeah, so what they say is, so hydrogen bonds are very strong, which means that these water atoms, right, are able to like get really close to each other. And that's why liquid water is actually pretty dense compared to solid water, which is ice. But then let's see what that says about solid. Okay, so when water freezes, the hydrogen bonds stabilize and they form a rigid crystalline lattice structure. And that this lattice structure will hold them apart further than they normally would be if they were in like a liquid form. So this is a very unique thing, actually, that this happens. This is very cool. Yeah, cool, which makes them less dense. And then, yeah, the practical effect. Yeah, it's very good. If solid water, like if ice sank, we would be pretty screwed. Or at least all aquatic life would be, which, if you believe in evolution, we came from aquatic life at some point. So, yeah. What's actually really cool is that in the winter, right, if you've ever been in, like, in a cold place, Bosnia, for instance, is pretty cold. You'll notice that in the winter, these lakes of water, like, end up freezing. But what ends up happening is only the top layer freezes. The entire thing doesn't turn into, like, a big chunk of ice. On the mountains, yeah, in the mountains, like, rain becomes snow. Yeah, it's a little bit different. Let me just get, like, an image of this. Let me say, ice, freezing, ecosystem, lake. Yeah, this is cool. It's actually important for a lot of stuff, actually. It's really cool here. Yeah. So, what ends up happening is, yeah, in the summer, okay, the top ends up being, pretty warm because that's where all, like, the sunlight is hitting, right? And then it gets colder the deeper and deeper you go. You've probably noticed this if you've ever been swimming in a lake, right? You notice it gets colder as you go further down. And so, I guess, right, in the fall, you have turnover, I guess is what they're saying. I guess everything gets the same temperature, so it starts moving stuff around. Because what happens, right, is that as water gets colder, it becomes, it sinks to the bottom, right? I think that's true. Let me see, like, density of liquid water with temperature. Yeah. Yeah, it becomes more dense as it gets colder. Yeah, so then it sinks. Yeah, it's actually it's really cool, actually. Yeah, let's get this image. I like this. This is a very cool image. Yeah. Yeah, so what happens is when the fall happens and things are getting cold, now this hot water at the top starts getting colder. And because it's colder, okay, as the temperature's going down, the density is going up, which means it's effectively heavier. And so that water on the top ends up, like, going down. And the water has to go somewhere, right? You can't just, like, keep packing down further and further. So this water on the bottom ends up, like, getting pushed up. And then it cycles around. And that must have great ecological effects because then you get to, like, stir up what we would say is, like, the soup of organisms. Stuff on the bottom starts seeing stuff on the top. I don't know. There's, like, interactions, and you have a really nice ecosystem with the animals. But then what happens in the winter is this top layer, so eventually it gets so cold outside. Let's say, for instance, it's like negative 30 degrees, that on the top, it will freeze. And what this does is this provides an insulating layer. It's like a giant blanket over the water, such that the water below it doesn't also freeze and turn to ice. It kind of it keeps it above freezing, and in doing so, this allows for these animals and fishes and whatever to like hibernate without freezing to death. It's pretty close to freezing, but they don't actually freeze. So yeah, and this is a very cool diagram. So yeah, the highest density of water. Yeah, it is interesting. It does occur. I remember it's at like 3.8 degrees or something centigrade. I think this is what it is. But yeah, so eventually you get to some highest point, and then as you start getting closer, it actually gets less dense until you hit 0, and then this is where the liquid turns into a solid ice really quickly, and then ice is only 92% the density of liquid water. So very cool. Yeah. Nice. Okay. Good question there, Ace. That's pretty cool. Okay, nice. Or not, or Ajner. Sorry, Ajner, you asked this question. Oh, Aj. Okay. Cool. Interesting. Yashua says turnover helps nutrients move around, but also unfortunately run off contaminants. Okay. Ooh, that's a bad thing. So yeah, what he's talking about is Google, chill. So yeah, unfortunately, there's a big factory here, and they're like making a lot of pollutants. And yeah, those pollutants like oil and whatnot tend to like concentrate at the top of the lake. But then this turnover does end up bringing that shit further down, which is bad for the ecosystem. But that's why it's important. Yeah, don't pollute the water. Okay, cool. All right, good question there, Aj. Here, let's do Equity's question. And then good. Ooh, we got parabolas with Moses. Cool, man. And then Azure, you got another question on optimization. I think that's really cool too. Okay, let's see. Equity, what's up? You around? Where is Sir Bob? What up, Equity? Equitas. Good job on your CS grade, by the way. Did your teacher actually help you out with that, with the computer science stuff? Yeah, it's always in our good grades channel. We love this. Students doing pretty well. Where was yours, Equity? Yeah, computer science. There we go. Look at that. 95. Good job. Huge big job to what was it? Yeah, dude, Jamarcus. Holy shit, dude. Just like, look at this. He's in the 8th grade and getting a nearly perfect score on the SAT. Like, good job there, Jamarcus. That's pretty nuts. I only took the SAT once and I got a 1420. And then I was like, whatever. I don't really need to try any harder. But good job, Jamarcus. 8th grade getting a 1580. That's nuts. I think this is the highest grade I've ever seen in my Discord. So, yeah. Yeah, you can post your midterm marks. I know you weren't taking math or science. It's okay. Yeah. Yeah, I didn't even notice the 8th grade part. Yeah, awesome. Yeah, pretty nuts. Yeah, Jamarcus has been in our server for a while. He's a really cool kid. I think we've had Jamarcus since like 6th grade. Yeah, he's been around. He's a cool guy. Right. Okay. In the diagram, blah 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 blah. To the vertices of ABC. If AB is a horizontal and BC is a vertical, determine the area of the right angle. Oh, there you go, Sensation. You got the jammies off? Like, got the jammies off?
Weather.
Do you drink coffee or tea?
Coffee.
Coffee, yeah. I made some nice coffee this morning.
Coffee.
Coffee. The big thing here in LA is now mushroom coffee. So they'll make coffee out of mushrooms. And
No.
I know. It kind of tastes like coffee, but they're like, oh, and the reishi gives you energy or something. But I'm like, bro, like nothing slaps like caffeine. Nothing slaps. I mean, unless it's like amphetamines. But shouldn't be putting that in your coffee.
And it's open to misinterpretation as well, because back when I was young, we used to sell something called mushroom tea.
Oh,
Now-
like psychedelic mushroom tea? Yeah,
Exactly that.
That's what, when I think of mushroom tea, I'm like, it's the psilocybin mushroom tea. But now
Yeah.
it's like not. It's like lion's mane or something.
And somebody will screw that up, and they'll like poison an entire generation of people by accidentally feeding them psilocybin.
Oopsie. Time for your morning routine to turn into your morning trip.
Well, at least a lot more people believe in God at that point, I suppose.
Oh, that's good. There you go. Or they're just nicer to other humans, you know. I say we do need to just like take the water supply.
Pretty sure that's a federal crime, playing with the water supply.
I'm pretty sure it is. Yeah, but it would be for the greater good.
I've heard that argument before.
It ain't time in sight.
I was just
Okay.
going to say, yeah, I've heard that before along the lines of Ein Volk, ein Reich, ein Führer.
Yeah, exactly. Equity, this is cool. These are cool questions. This one's pretty easy, man. You should be able to do this. So, useful for part B, the sum of K. I want to do part B. Part A is easy because the area of a right triangle, right, is just length times height times 1/2. And you know that this is just going to be 6,3, right? Because this has to be the same height as this one, 3, and it has to be the same length x as this one, so 6,3. 1A and 1B were pretty. I mean, part B might be hard. All right, let's do part C. Let's do part C. Yeah, exactly. There you go. Yeah, let's do the challenge. I want to do the challenge. Looks like it's getting real nasty here. Let's do a workout. Okay, quadrilateral has these vertices. Okay, cool. The quadrilateral QS is a diagonal and divides into two triangles. There's one positive integer C with the property that the area of PQRS is 180. Determine the value of C. Oh, 1B is not the only question in part B, by the way. Oh, I see. Oh, like this is necessary for probably this. I think it probably is somehow. Yeah. Yeah. Let's take this. This says useful fact. We probably need it. This looks like a Is this a series? Yeah, this is a series summation. This is a summation identity. It's cool. Okay. Yeah, what level math is this? Oh, there's more to it? Okay. Yeah, ask us tomorrow. That's cool. Yeah, let's just try to do this one. Okay. Well, I know if I draw... Let's try to, like, break this into triangles I know that are right? So I know this will make a right triangle, guys, right? All right. This should make a right triangle, right? And so this would be at 28 comma C, right? And then this would be also a right triangle, which would be at 25 comma C, okay? Yeah? So then let's try to, like, do all the triangles, I think. That's how I would approach it, okay? Again, I know this one is 25 comma C because it has to have the same X coordinate as this one, and then it has to have the same Y coordinate as this one, okay? So I'm going to call this, like, triangle 1. I'm going to call this triangle 2. I'm going to call this triangle 3. I'm going to call this triangle 4. And then, yeah, because these are going straight down and hitting this, I know that these are 90-degree angles. Okay. So let's do triangle 1. So triangle 1 has a base of 25 minus C. So I'm going to say, okay, area is equal to 1/2, 25 minus C, times the height, which is c plus 2 minus c. So that's just equal to 2. Okay, that's not too bad. This one is going to be 2c minus 25. So 2c minus 25 times the same height, which is, again, just 2. Okay. Triangle 3 is going to be 1/2. Now the base is 28 minus c. And that has a height of c minus 4. Right? Because this is c, and then this is 4. And then the other one is going to be 2c minus 28. And the height is also c minus 4. And then we're told if I add all of those up, I should be equal to 180. Okay. So, first of all, since all of these things have, what's up? Yeah, there's our Discord dog. All these things have 1/2s in them. I'm just going to get rid of all these. And then just say that this is all equal to 360. Right? Because it's 1/2 blah, 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 plus 1/2 blah, 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 right? Equals to 180. So I can just multiply both sides by 2. Just to get rid of the 1/2, because it's just kind of annoying. Okay. So then I have 25 minus c times 2 plus 2c minus 25 times 2 plus 28 minus c times c minus 4 plus 2c minus 28 times c minus 4. And this is just going to be a lot of annoying factoring. Okay, so this is 50 minus 2c plus 4c minus 50. Well, that's cool. At least the 50s go away. Okay. Plus, this is going to suck. So that's what? Negative c squared, because minus c. And then that's going to be 28c plus 4c, so it's plus 32c. Right? 28 times c, negative 4 times, yeah, good. And then minus, 112. Yeah, right. Okay, thank you. Good. Okay. And then this is going to be plus 2c squared minus 28 and positive 8 is minus 20c. And then adding those together is another 112. Oh, 36? Where'd I mess up? Oh, you're all right. You're right. Sorry, I forgot the minus is on this as well. Yeah, you're right. That's minus 36. Good catch. Good catch. Okay. And then this all has to equal 360. Okay. So luckily the minus 50 and the 50 go away. Minus 112 and the positive 112 go away. Minus c squared and 2c squared, that's just going to be c squared. We got rid of those. And then minus 36 plus 32 plus 4. That's 0c. So then this is minus 2c. That's the only one that's left, right? Minus 2. Wait, did I get that right? Sorry. Yeah, minus 2, right? Yeah. Okay. Okay, and then this is equal to 360. So I'm going to say minus 360 is equal to 0. Do these have a nice, do I have a nice multiple of negative 3 to negative 360? I got like 120 and 3, 60 and 6. 30 and 12. Oh, Ashner, sorry, what? 18 and 20. Yeah, I believe. Yeah, so you have C. Yeah, 18 and 20, right? Yeah. This is C minus 20. C plus 18 is equal to 0. So then C must be equal to 20 or negative 18. But I think from here we saw it was in the positive axis. So answer should be C is equal to 20. Let me see, Ashner. The final answer is that there is no positive integer C that satisfies the condition that the area of PQRS is 20. The area of PQRS as calculated in the previous response is 81, not 180. Therefore, there is no solution for C that meets the given area requirement. Is that what ChatGPT told you? It sounds kind of weird. Yeah. Thanks for the... Yeah, thanks, Poingalis. Yeah, C equals 20. I think C equals 20 is correct. Yeah, that's a cool one. Nice. Good job. I think that's right. Wasn't too bad.
Well done.
I made this look easy. No, I appreciate that you think it looks easy. I mean, no, it looks fucking hard, honestly. Also, I don't know why this is here. Maybe this is for the later parts of the questions. No, it's okay. It looks tricky at first, but dividing it into 4 triangles and then just realizing that all of these are related to these variables using this makes it easier. And then there's some algebra tricks. Yeah, but anyway, it's a good question, dude. Yeah, ask us for the math. Yeah, good job, Equity. Nice. No, I like these. These are cool. Kind of fun. Agree, Yashua. Yeah, it's about making sure you take your time on the algebra. Yeah, because I could have, and I did mess up here earlier. Like, because there's just so much foiling going on. It's kind of a mess. But not bad. Good question. Let's see what Azure is asking. Foil this, foil that. I hate foil. I really don't. I really don't like foil. You want to see what I you guys saw what I used earlier with the Punnett square method, dude. Let's go to my YouTube. I have it on here somewhere. Where's my accounts? No, that's my other account. Where is me? Where is me? Let me see. How to foil. Like one of my videos though. One sec. Switch account. Oh, I'm on Actual Education. Okay, one sec. There we go. YouTube Studio. I'll find it. I have to find my videos. What is the video? I don't know. My FYP is all weird because I follow whoever. People say like, "Hey, support my YouTube channel," and I just like subscribe to everybody because I'm like, "Yeah, cool. You can have it." I'm trying to find foil. Where is it? Yeah, here we go. How to multiply without the foil method. I think it was... Wait, why do I have 2 videos? Oh, I think I did one as a short before they had shorts. Maybe it was this one. The comments. No, that wasn't... It wasn't this one, was it? I think it's this one. Yeah. Anyways, okay. Here's a quick trick for multiplying binomials. So here we have 2 binomials, x plus 3 and x minus 4. Can't you upload 3-minute shorts now? You can, apparently, but it hasn't rolled out to my account yet, which is super annoying because I always have to break things up into like 4 parts. But this is actually one of the first videos I ever made back in like 2021. And we're gonna put the terms from. And so I show how I like doing foil like this. I like doing like a Punnett square. Is look at the intersection between and then I do this. I multiply this by this, this by this. So here, this is x times x. And everyone's like, so foil, but time consuming. I'm like, it depends, dude. I mean, for simple binomials, I agree. First out or inner last is probably faster. But as you saw on, what was it? It was, what question was it? Is it this one? Yeah, it was this one, I think. Yeah, right? Once you start doing, like, trinomials times binomials, it's a lot easier to do it as a Punnett square. So I tried telling them this. And then someone's like, literally foil? I'm like, it's foil with a cosmetic facelift. Bro, that's just you don't know how many times I get like the same comment of like it's just FOIL. But then some people really like this. Yeah, this has a lot of advantage for working with expressions more than 2 terms. I'm like, yes, exactly. People always get so mad that this is basically FOIL. And I tell them, yeah, try to FOIL 2 trinomials together, dog. Yeah, I hated FOIL. Anyways, it's controversial. It's good for the algorithm. They love it. Anyways, okay, so yeah, where were we? This. Okay, cool. You have no idea what FOIL is? Okay, it's first, inner, outer, last. So I think what happens if you have A plus B times C plus D, I think they do A times C, so that's the first ones, AC, inner, B times C, and then they do the outer, which is A times D, and then the last, which is D times B. I think that's what like first, outer, inner, last is. But then again, this doesn't really work if you start doing this. Because then it's like, uh-oh. Like, which ones, how many inners do I have? FOIL's also used in biology. I think the Punnett square is used in biology. Yeah, doing it this way with genetics, yes, is very much used in biology. It's super helpful. All right, Azure says, find the dimensions of a rectangular box with a square base, an open top, and a volume of 32 cubic feet that minimizes the amount of material used. This is a really cool question, actually. I like this. Oh, I got you, dude. Yeah, let's do some astrophysics and quantum, Dennis. I'm super down for it. Okay. Oh, so it's a square base. Okay. Okay, so that's like A, an open top and a volume. Okay, so we don't know what this is, right? This is B. Okay. So the volume is 32. So we know that means that the area of the base times the height, so A squared B must be equal to 32. And then if we want the volume of material used, that's the surface area, right? Which is going to be the area of the base plus 4 times the area of the sides, so 4AB, okay? And that is going to equal to the surface area, which we're trying to minimize. We're trying to minimize this, okay? So when doing this, I want to write everything in terms of just one variable, which in that case, I can see that A squared is equal to, well, let's see. Yeah, A squared is equal to 32 over B. So, well, no, actually, I want to write B in terms of something. Okay, sorry. B is equal to 32 over A squared. So I can now substitute that into here. So I get A squared plus 4A, and now this is 32 over A squared, and that's equal to surface area we're trying to minimize. Cancel. A squared plus 32 over A is equal to surface area. This is unfortunately not a nice parabola or anything. So I could use calculus, find out where the derivative is 0, and then do stuff. But that's gonna require me doing like, oh man, it's just gonna look ugly. So I'm just gonna graph this. The other way to do is just graph it. Okay, so let's graph A squared plus 32 over A. Trace it out, and it's gonna have a minimum somewhere. Oh, yeah, plus 32 over A. Yeah, there we go. Let's zoom out. Right, come on. Where's the minimum? Does it never come up? There we go. Interesting. Wait. A squared B, I'm right with that. A squared B is 32. So B is 32 over A squared. So A squared plus 4AB. B B is 32 over A. Oh, I forgot to multiply the 4 times the 32. Uh-oh. Got him. Don't forget that, Geo. That's 128. Thank you. How can you send something? There is a channel. Oh, sorry, I haven't even been watching my YouTube. Have you been watching the YouTube for me, Sensation?
I've been trying to keep up with it.
Oh, okay. No, I appreciate it. Thank you. Oh, you can post links now, right? Because you're a mod?
Aye.
Aye. Good. Okay. I would have known that, but our teacher gives us 3 sheets for us to learn, and she doesn't do anything. That's unfortunate. Yeah, okay. Are you in a calculus class, Ajner? Because I feel like you need a calculus class to do this. Okay. You want to find out where the surface area is the least. Man, this is a pain in the ass, this one. Because I feel like the minimum happens... One sec. Let's see whether I have this right. A squared plus 4ab, right? 1, 2, 3, 4. 4 sides. That's that. So 128 over A. And you want to minimize this. Okay. Let's just plug I can do the derivative of this. Let's just do it. All right, fine. The derivative of this is going to be 2a minus 128 over a squared. And you want that to be equal to 0. Okay. So if I put that in, I get 28 is equal to 128 over a squared. Let's multiply that through. 2a to the third is equal to 128. Divide by 2. A cubed is equal to 64. A is equal to 4. You could do AM minus GM. Oh, okay. What is that? That's actually a weird method, Point Gala. Sorry, what is that? AM minus GM? Oh, absolute minimum versus global minimum? What's AM and GM mean? Sorry. Yeah. Okay. Oh, a squared equals 64 over a. Equality is when a squared equals 64 over a. Oh, I like that. Yes, good. Yeah, you're right. Okay. A equals 4. All right. So what I really should check, though, is to see if that's a max or a min, is take the second derivative of this. Okay. Which the second derivative of that would just be 2. And then it's plus 3 times 128. What's that? 384, I think. 384 over a cubed. And that is going to be positive. Okay, cool. Yeah. So if the second derivative is positive, it means it's concave up, which means it's a minimum. And because the derivative is 0, we're at what's called the critical point. So a is equal to 4. So you say, okay, cool. So base length is equal to 4. And then we say the height, so that was A. So 16, so, the height is equal to 2. Because 4 squared is 16, and 16 times 2 is 32. Cool. Does that make sense? Ajner, you had to do some calculus there. That's okay. Okay, here. Let me help out OG. Got a little bit of time before I got to go to another student. How long are we in 2 hours? Oh, arithmetic mean is greater than geometric mean. This is the trick to avoid derivatives. Oh, yeah, that is, wow, that's very creative. Oh, that's cool, Point Gallus. Yeah, okay. Arithmetic mean is greater than, wow, okay. All right, let's see this. This is physics, I think. This is cool. Marie throws a ball, blah, 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 blah. Okay, Alan is in the same gymnasium. He throws a ball whose height can be modeled by the following function. Love this. It's on Earth. Okay. Whose ball gets closer to the ceiling and whose ball falls back to the ground first? Hint, okay, yeah. They're just like, Suvat. Okay. Yeah, I miss physics. This is cool. Okay, so let's say for Marie. So Marie has her equation as being y is equal to the initial height, right, which is 2, plus 19.6t, and then that's going to be minus 4.9t squared. And then Alan has his y as equal to 3 plus 14.7t minus 4.9t squared. So it's actually cool. So we can see, right, Marie starts from lower down, but with a higher initial velocity. Alan starts from higher up, but with a less of an initial velocity. So which one gets closer to the ceiling? You could plot these two and try to figure out where the vertex is, which, so yeah, here's a question. Is this a physics question or is this a calculus question? Or is this like a pre-calc question or is it a calculus question? What equations am I allowed to use in this? Mosey. This is algebra 2. Okay, cool. So I'm not going to use physics then. All right. These are two parabolas, which are going to look something like this, okay? And I want to figure out how high they get. The way to do that is to know that I did Asner. Yeah, Asner, I did it here. The height was 4, the length is 4, height was 2. I had to use calculus for it. But here, I'll dump it for you. Okay. So if you have an equation, ax squared plus bx, yeah, exactly, good. And it's a plus c is equal to 0, right? Or no, yeah, it's equal to y, sorry. Then the vertex is at negative b over 2a, right? Which you can solve for both of these, right? So if I do for this, right, I get negative 19.6. Or actually, yeah, no, that's okay. Negative 19.6 over 2 times negative 4.9. And then this one is negative 14.7 times 2 times negative 4.9. But that just tells me the x position of the parabola, right? So that just tells me what the time is when it hits the max. So if I want to figure out where that is, I then need to plug this in for t for each one. Okay? Yes, you plug this back into the equations. Yeah, doing that, let's just, yeah, because I don't want to, like, it's kind of a pain in the ass to plug that in. I'm just going to graph it. But you know what to do. Minus. Well, let's see. So this is his. And this is his 3 plus 0.7x minus 4.9x squared. Cool. Let's graph them. First one's that. Second one's that. Okay. So Marie gets closer for sure, right? So Marie's gets closer. I tried doing this by hand. Yeah, I know. It just sucks. Because you're going to get a number for this, which is a decimal, and then I'm going to have to plug it in for the squared and for here, and these are all decimals. So it's possible. You can do it. To save time, because I got to teach a student pretty soon. I just want to make sure you get it. Okay, assume no one caught either ball. Whose ball hit the ground first? Okay, this is kind of cool. So to do that, you want to find the x-intercepts, right? But Alan's is to the ground. I agree. Yeah. You can see that from the graph. The other way is just set this equal to 0 and just solve for it. And then that's using the quadratic equation. My graph spoiled it. Yeah, I know. I know that lovely quadratic formula. Yeah, you're right. Well, here, we can actually, but let's kind of show how it works. So this is 0, say a maximum of, I don't know, probably 10 seconds, right? 10 seconds is probably the max. 0, or let's say -1. And then let's put the y max up at, I don't know, like 30. You said that it was 30 meters high, right? Yeah, it's a, oh, we need to really extend the time here. 1 sec. Yeah, x max is probably like 10. There we go. So that's the first guy. That's Marie, and then that's that one, yeah. You're learning this right now, Aduki? Oh, that's pretty cool. So yeah, so that's how you could figure it out. Get it, plug it in, and then use the quadratic formula to solve to see what you get for the times. You're going to get a positive answer and a negative answer, but you want to keep the positive answer because, again, that's the answer that makes sense. You can't have negative time. So, yeah. Good question there, man. That was a fun one. Time can't be negative. No. Cool question.
Well done.
You're very lucky.
Well done.
Who's this? Who did I help out here? Who's this? This was Mosey. What are you in my Discord, Moses? What are you? OG. Oh, Dread. Okay, there you go, Dread. My bad. Okay. Unfortunately, I have to go teach a student in like 30 seconds. Man, Dennis, I wanted to do your question. And S14, you guys had good ones here. Wow, yeah, index of refraction. Yeah, this is cool. No, Ajner, you only get 1 point. You only get 1 point per question. And then Simeo. Calculate. Ooh, wow, what is this? dy dx? Oh, if. Oh, this is in Spanish. Is this Spanish? Oh.
Looks like French to me.
Looks like French. Here, let me do this real quick, just because I think I can do this one quickly. Dennis, I would want to do yours, but it's going to take time. And this guy's never asked a question before, so let me do his real quick, and then I'll just tell the other kid I'm going to be 5 minutes late. But then, Dennis, I'll do yours tomorrow, if that helps. Because I enjoy learning the stuff you're doing. It's pretty cool. Okay, this is implicit differentiation. So what I'm going to do is I'm going to take the derivative of everything kind of individually and see what happens. Ew, this is a mess. Okay. So here we go. Okay, we'll do the yeah. Let me know if you really need help on it. I can do it after I'm done teaching. I'll send you the screenshot for it. Okay. So the derivative of e to the something is always just e to the something times the derivative of what's inside. So for here, I'm going to get e to the x minus y times the derivative of x minus y, which is going to be the derivative of x is just 1, but then I'm going to write dx, and then I'm going to say the derivative of y, which is 1, but then I'm going to say minus dy. So here's my trick for doing these, is that every time you treat every variable as something you need to take the derivative of, and then whatever you did that variable's derivative of, you write dx or dy afterwards. Okay? So when I did this, I was like, okay, e to the something, the derivative of that is just that same e to the something times the derivative of what's inside. And the derivative of x minus y would be 1 dx minus 1 dy. Because the derivative of x is just 1, but I took the derivative of x, that's dx. And the derivative of y is just 1, but I took the derivative of y, so that's dy. This is 0, because that's a constant. This is 0. Okay. And then doing this is tricky, because this is a product rule and a power rule. Okay. So derivative of the first, so derivative of x is just 1, but I took derivative of x, so it's dx. So it's minus y squared dx. And then derivative of the second, which is 2y dy times the first, which is x. So I'm going to say 2yx dy. Okay? Again, I'm just going to go through this quickly because I have to go teach someone else. But I want you to at least see this. You can ask me next time. I can explain more of the steps of how this works. Or if you found me on YouTube, I do this on YouTube. I have a YouTube short on this one, on how this works. Minus y squared dx minus 2yx dy. Okay, now the important thing is to group everything. So I'm going to put all the dy stuff on one side and all the dx stuff on the other. Okay. So that's going to get me e to the xy plus y squared dx is equal to is equal to e to the xy minus 2yx dy. And then I'm just going to divide both sides by the shit. So this is going to come over here. Okay. You're the goat. I appreciate that, dude. That's cool, man. So that goes over here. That goes underneath. Then this comes under. This becomes dy over dx. And there you go. That is your answer. Nice. Good job. Here, I'll save this as a PNG for you real quick. Use this.
Well done.
So
Well
Simeo,
done.
Julian. There you go, Simeo. Okay. Cool. Awesome. There you go, Simeo, and I'll give you a point for it.
So, do you remember
yeah.
when acronyms used to have a full stop after every letter in an acronym?
What do you mean? You used to have a full stop?
Back in the 90s, like CPU, for example, it was C period P period U period.
Oh,
to,
yes,
to note that it was an acronym.
Yes.
So we need to normalize making acronyms again.
Oh, instead of just make them all. They make NASA. They make it all capitals. Oh, thanks, Aduki. Yeah, appreciate that. Dude. Real quick, Moses says, "What would you recommend taking before jumping into calculus?" I would pre-calc. It's literally called pre-calculus. You learn all the tools you need to use for calculus. That's what I would recommend taking. MAGA with the periods. Oh god. Okay. Anyways, all right. I gotta run the stream because I'm late to a stream. Anyways, awesome. Thanks everyone for coming out. Appreciate all you guys coming out. Our next stream is gonna be tomorrow. That'll be at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. If you ever want to know when we're streaming, there's our calendar. You can always check this out. It will show up in your time zone. It's great. And it also shows all of our other awesome math streamer friends that do live stream math help. So, tomorrow we got either 2i Pi, Zach is teaching, Penn Center's on Wednesday. Looks like there's no one else today. These streams are always so interesting. Man, I appreciate that, dude. Thanks for coming around. Yeah, I mean, go tell your friends and everything. We like to have a good time. But anyways, let's go.
I just like to annoy people, and there you go.
You missed me yesterday, Azure. I'll get to it. Just DM me. I do make mistakes. It's not often, but it's okay. I'll figure it out for you. This calendar doesn't show up in your time zone. Oh, you're right. Sorry. Yeah, sorry. It only shows up in the Pacific time zone. Yeah, that's Google's fault. But it at least shows a red line of where your time is, so you can kind of calculate where the streams are, I guess. If you add it to your Google Calendar here, I think if you click the button here, then you can choose to have it shown in your Google Calendar in your time zone. So add it. Where the crap is that? Yeah, Obi, that's it's under that calc thing. Yeah, red line where Pacific time is. Yeah, exactly. Yeah, LA time, best time. All right, let's go raid someone. Yeah, Obi, let's get you added to the calendar. Talk to Penn Center so that we can have your streams on there.
LA time is not best time. GMT is best time because it's the center of the earth.
Yeah. Okay, who do we got? Just watching AI videos. And okay, cool. Microscope Monday, dinosaurs. What's he doing? I don't know. Let's go see Globus. Globus is kind of cool. I like Globus. All right, go say hi to Globus. He's talking about AI stuff. I think AI is pretty cool stuff. So, go say hi to Globus for us. And otherwise, have a wonderful rest of your Monday. Great start to your week. And we will see you tomorrow. All right. Peace out.